Most students find fractions to be intimidating. I've often found that this is because they understand fractions as abstract objects that follow strange rules rather than having an actual understanding of what any of it means. We will focus on the development of the ideas before we develop the mechanics. In the previous chapter, we talked about division as making groups of boxes. But 4 groups of boxes can look differently depending on the division problem in question. 16 divided by 4 gives us a grid with 4 groups of 4, and 24 divided by 6 gives us a grid of 4 groups of 6. This creates a small problem because even though both pictures represent 4 groups, one picture is clearly bigger than the other. There are a lot of ideas related to percents and proportions embedded in these pictures, but we'll look at those later. To make these pictures more uniform, we will use wedges of a circle, like slices of a pizza, to represent the groupings instead. This way, one grouping will always be represented by one full circle, regardless of the number of pieces. We call pictures that use these circles and wedges as pictures of parts of a whole. Example, use parts of a whole to represent 2/5. Representing a fraction using parts of a whole means drawing a circle that has been cut into a certain number of pieces and then shading the right number of pieces to represent the ones that we have included. Recall that in a fraction, the denominator represents the number of pieces needed to make a full grouping, and the numerator represents the number of pieces that we have. So in this case, we have 2 out of 5 pieces needed to make a full grouping. So we will draw a circle and break it into 5 parts and shade 2 of them in. It is difficult to draw these perfectly, but do your best to draw the wedges so that they are about the same size. This will help to build some geometric intuition. At the beginning of Chapter 3 in your book, you will see pictures of parts of a whole with different numbers of wedges. You can use those pictures to help guide your drawings. Example, use parts of a whole to represent 2 1/3. In this picture, we have 2 full groupings plus 1 out of 3 pieces needed to make another grouping. When drawing out the full groupings, it's not necessary to cut them up into pieces, although it doesn't actually hurt to do that. For the fraction part, we need 1 out of 3 pieces shaded in. An improper fraction is a fraction where the numerator is larger than the denominator. This means that we have more wedges than we need to make a complete grouping. In order to work with this, we will make complete groupings out of those wedges and look at what's left. Example, use parts of a whole to represent 7/3. This says we have 7 wedges, and we require 3 wedges to make a complete grouping. You can imagine this situation as if you had physical wedges made out of paper or plastic that you can slide around the table. What we're going to do is take these wedges and slide them around the table to make full circles. We can see that if we do this, we end up with 2 full groupings and 1 out of 3 pieces needed to make another grouping. In the end, we don't need to have a picture of all the individual wedges drawn out and a bunch of arrows. We just need to see the final result. Example, use parts of a whole to represent 15/4 as a mixed number. To do this, we just need to look at the picture. We have 15 total wedges and we need 4 to make a grouping. So we will count them out as we color them in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. When we look at this picture, we see 3 full groupings and 3 out of 4 pieces to make another grouping. So 15/4 is the same as 3 3/4. Example, use parts of a whole to rewrite 3 1/5 as an improper fraction. This is the same basic idea of the previous section, except we're going in the opposite direction. We will start out by drawing the picture. We want to count up the total number of wedges we have if it takes 5 wedges to make a complete grouping. In order to do this, we will draw in the wedges into the picture. From the first circle, we get 5 wedges, and then 5 more from the second, and 5 more from the third, for a total of 15 wedges, plus the one that we had left over. This means that 3 1/5 is the same as 16/5. It is important to take the time to draw these pictures to continue to build your intuition about fractions.